Hi friends, in this video we are going to study about Program Evaluation and Review Technique PERT. We will be solving some examples based on this technique. What is PERT? It is the acronym for Program or Project Evaluation and Review Technique in which planning, scheduling, organizing, coordination and controlling of uncertain activities take place. It is to be noted that this technique was developed specifically for activities or projects which are uncertain, which is done for the first time, and there is no experience or knowledge for it before that. The technique studies represent the task undertaken to complete a project to identify the least time for completing a task and the minimum time required to complete the project. It was first developed in the late 1950s and was aimed to reduce both time and cost of the project. PERT is used in non-repetitive and uncertain conditions only. It is said that it was first used for experimental and research purpose of missiles. PERT uses time as a variable, which represents the planned resource application along with performance specification. The project here is divided into activities and events. Proper sequencing is also required in this technique, and the network diagram has to be constructed. PERT is completely probabilistic and uses a range of time within which an activity can happen. Thus, the PERT majorly uses three types of time or activity durations, which are all probable. First is optimistic time, which is also the shortest duration required to complete the task. Next is pessimistic time, or the longest duration required to complete the task. Third is the estimated or expected time, and it is an average of the shortest and the longest one, or can be the most best estimated duration for the task to complete. Since we have three time estimates now, it is important that now we calculate the weighted average duration required for the activity using optimistic, most likely, and pessimistic times. The formula for this, and it is very important, is optimistic time plus 4 times the most likely time plus pessimistic time divided by 6. This formula will be frequently used to calculate the expected duration of an activity in further slides. The pessimistic time, optimistic time, and most likely time are represented as P, O, and M in these following probability curves. You can see that depending upon the range of these durations, the curve pattern varies, and thus to evaluate the curve against time versus number of instances, one will require the probability chart or the Z table. The key differences between PERT and CPM have been listed below. PERT stands for Program Evaluation and Review Technique, while CPM stands for Critical Path Method. PERT is completely probabilistic method, whereas CPM is a deterministic model, and the working for CPM is done with certainty and experience. PERT uses three types of times, and it often has uncertain times for the activities, while CPM deals with activities of precise, well-known times. PERT is used for jobs which are one-time projects. CPM can be used for completing projects which are repetitive in nature. Orientation PERT is activity oriented, whereas CPM is event oriented. PERT does not include any dummy activities. CPM makes good use of dummy activities to represent proper sequencing of activities. PERT has nothing to do with cost of a project. CPM deals with also cost of project in the schedules and helps in resource allocation, leveling, and minimization of cost. PERT is a restricted to time variable, while CPM also includes time cost trade-off. Moving further to variance and standard deviation in a PERT calculation. As told that the values received from PERT calculation is completely probabilistic. Therefore, it is essential to find out the variance in the results and the standard deviation, the formula for which is shown. The expected time of activity is optimistic time plus 4 times most likely time plus pessimistic time, the whole divided by 6. Whereas the expected time of a project is calculated by the sum of all these expected times of critical activities. In case there is dependencies shown for the activities, a network diagram has to be prepared and then duration calculated on the critical path. The variance of an activity is calculated as pessimistic time minus the optimistic time divided by 6, the whole square. Whereas the standard deviation of the project is the square root of the sum of all the variances of activities on the critical path. Therefore, the formulas of variance and standard deviation is to be noted. Once we obtain the standard deviation, we can calculate the probability of completion of a project by any x time. For this, we will require the z table. Therefore, the z number is equal to the probabilistic time x minus expected time t divided by standard deviation of the project. How this formula is used, we will see in the example. Probability of completion example for a PERT schedule is given. There are 5 activities A, B, C, D, E. The optimistic time, most likely time, and pessimistic times are given. Since there are no relationships mentioned, it is assumed that these activities are all critical and have a finish to start relationship with each other. So we have to first calculate the project duration. The next questions given are to find the probability that the project will finish by end of 32 days. Also find the probability that the project will finish by end of day 34. PERT, probability of completion example. The first step is to calculate the expected duration and the standard deviation for each activity. Therefore, we prepare this table. By using the formula that we have earlier studied, that is optimistic time plus 4 times mean time, or the most likely time plus pessimistic time divided by 6, gives the following values. The sum of these values will give the project duration since all activities, that is A, B, C, D, and E, are on the critical path. Here, the total sum comes to be 32. Hence, the total project duration or the first solution to the problem is 32 days. Further, we carry out the calculation of standard deviation and variance. By using the formulas, we come to the conclusion, and the sum of all the variances in this activity is found to be 8.832. Taking the square root of the variance, we obtain 2.972 days. So the first question to calculate the probability that the project will finish by the end of day 32 is done by using the formula of z is equal to the estimated time, that is 32, minus expected time 32. In this case, since we are talking about completing the project by end of day 32, dividing it by 2.972, we get 0. Now let us look at the Z table. In the Z table, we can see 0 correspond to 0.5% or 50%. Therefore, there is a 50% probability that the project will finish by the end of day 32. Next, the probability that the project will finish by the end of day 34 is given by the following formula, that is equal to 34 minus 32 divided by 2.972, which we get 0.672. Now this value can be traced in the Z table, and it comes to about 0.7486 or 74.9%. Therefore, the solution is there is a 74.9% probability that the project will finish by end of day 34. There are also some more complex examples which have been solved for your reference. That is to calculate the probability that the project will finish before day 30, the probability that the project will finish at least 2 days late, and the completion date with at least 90% confidence level. And some questions have been given for your practice. Let us come to the first question. The probability that the project will finish before day 30, that is, if we have to complete the project before the 30th day, that means we have to complete the project in 29 days. So the expected time is 29, while the calculated time duration was 32. Divided by 2.972, we get minus 1.01. So when the z value is less than 0, take the probability that corresponds to the positive value of z and then subtract it from 1. Here from the z table, when we look for 1.01, we find the value 0.843, which is subtracted from 1, and thus we get the value 15.7%. Therefore, there is a 15.7% probability that the project is going to finish before the day 30. Next, the completion date with at least a 90% confidence level. In order to calculate this, we will first look at the Z table, and for 90%, we will find out what the Z value is. Here we find it to be 1.28. We also have the project duration 32 calculated. Therefore, the formula for calculating the expected duration is shown here, and the answer comes to be around 35.8, which is rounded off to 36 days. Thus, PERT helps in the probabilistic determination of various time durations for schedules which do not have any certain time allotted to these activities. There are often various critics for this type of method for obtaining a valid time estimate from three different time estimates, and often it becomes difficult to arrive at one activity time. Nevertheless, this technique is widely used. Now, the last example, that is the probability that the project will finish at least 2 late, is also solved for your reference. Thank you.